In this tutorial, I am going to teach you how to calculate percent composition by mass. A lot of teachers just simply refer to this as percent composition. It's a really easy skill. So what skills should you have prior to learning this lesson? Not a lot. You definitely need to know how to use molar mass, how to calculate molar mass. And it's honestly really helpful if you know how to use your chemical nomenclature skills correctly. Just in case they would give you the written name instead of the formula, you would need to be able to write that formula so that your math is correct. Now, in a nutshell, this is today's lesson. To find percent composition of a specific element within a compound, you are going to divide the total molar mass of that specific element by the total molar mass of the entire compound. We will multiply by 100 to convert it to a percent. We're going to round to whole numbers today, and like I said, this is just really easy. I'll do several examples with you and then give you the opportunity to try a few on your own. So go ahead and make a note of this, and once you've got that written down, we'll start on some examples. So, question number 1 says calculate the percent composition of oxygen in carbon dioxide. So they have given me carbon dioxide, and based on the mass that I find for that molecule, what I'm wanting to know is what percent of that mass came specifically from those oxygen atoms. So I like to start these problems off by simply finding the molar mass just the way we did it in that molar mass video. So we're going to back up a little bit. A lot of you are just finding that mass real quickly now, just punching it in your calculator, maybe doing a little scratch work on the side. Just to teach you this concept, we're going to go back to where we wrote everything out and showed all of our work, and you'll see why. So carbon dioxide has 2 atoms in it. We have carbon and we have oxygen. We have 1 carbon and 2 oxygens, so we're going to take an atom inventory. And now we're going to multiply those numbers by the molar mass of each element. So the molar mass of carbon is 12.01 grams per mole. I'm not going to write the gram per mole because this is kind of still scratch work. The molar mass of oxygen is 16.0 grams per mole. So let's multiply those across. 1 times 12.01 is just simply 12.01. And 2 times 16 is going to be 32.0. We're going to add those two numbers together. And when we add 12.01 plus 32.0, we are going to get the molar mass of carbon dioxide, which is 44.01 grams per mole. So essentially what I just did here was the molar mass lesson. That's it. Now we're ready to do the new thing that I'm going to teach you, and that is how do I find the percent oxygen by mass in this carbon dioxide molecule. So I want you to write percent oxygen equals, that's just everything labeled nicely so you can follow your work. And what you want to do is take the total of the specific element that they're asking you for. They're asking you for oxygen. The total mass of oxygen is 32.0. That's where you want to be careful. You don't want to pick 16.0. You have 2 of these and you have to account for them both. So the total mass of oxygen is 32.0, and we know that's grams per mole. I'm just going to go and write it down. The OCD in me has to do it. The total mass of the entire molecule is 44.01. That total mass always goes on the bottom. So 44.01 grams per mole. Times 100, that just simply gets it into a percentage. And you should be getting, let's punch that in, 32 divided by 44.01. I am getting about 73%, and that's rounded. So the answer is 73% oxygen. That's all you do. So hopefully now the little shortcut that I wrote for you earlier, the total molar mass of the specific element, in this case it was oxygen, divided by the total mass of the whole thing. That's why I like to write everything out, because I can see exactly what I need. So it's always going to be one of these numbers, whichever one you're being asked to solve for, over that total. Let's take a look at the next one. Calculate the percent hydrogen in sulfuric acid. Now, something I want to point out, you could get a question where they just give you that. So that's why I mentioned earlier, make sure you know your nomenclature, because you've got to be able to write this formula correctly so that your mass is right. Here we're giving it to you, so it's not such a big deal. So get this up here. So we're just looking at this problem. We have hydrogen, sulfur, and oxygen. So we're going to take our atom inventory. We have 2 hydrogens. I'm just looking at that little subscript. We have 1 sulfur, and we have 4 oxygens. So we've counted how many of each, and now we are going to look at the molar mass on the periodic table, and we're going to write those masses down. So the mass of hydrogen is 1.01 grams per mole. The mass of sulfur is 32.07 grams per mole. And the mass of oxygen is 16.0 grams per mole. So let's multiply everything across so we have our totals for each individual atom. So this is going to be 2.02 for the hydrogen, 32.07 for the sulfur, and 64.0 for the oxygen. And again, I just multiplied. 2 times 1.01 is 2.02, and so on and so forth. So let's add these together. And when we add those 3 numbers, we should be getting around 98.09 grams per mole. Now let's say you punched this in, you were doing the math, and you got 98.08. For a problem like this, it's not such a big deal. We're rounding to a whole number. Now we've got our molar mass of the entire sulfuric acid molecule. But the problem is asking us for the percent hydrogen. They want to know what percent of the mass of that sulfuric acid molecule came from just hydrogen. So we're going to divide our total mass of hydrogen by the total of the whole thing. So our percent hydrogen equals, so write percent H equals, that is just you keeping everything labeled nicely so you can follow your work. 2.02 grams per mole, total mass of hydrogen, over 98.08 grams per mole of the whole thing, times 100. And that should be giving you approximately 2.06%. So 2.06% hydrogen. I went ahead and went out 2 decimal places on that just because that's such a small number. If you put 2%, that's fine. Again, these typically, especially for beginning chemistry students, aren't super picky. And you know, I look at that and that makes sense because hydrogen has such a small mass and there's only 2 hydrogen atoms in H2SO4. You know, just eyeballing it, the largest percentage of my mass is coming from the oxygen, followed by the sulfur, and then the hydrogen atoms. So let's take a look at another one. Hopefully you're like, I've got that, I don't even need 2 more, but just in case everybody works at a different pace, we're going to do 2 more and then I'll let you try some on your own. So number 3 says, calculate the percent composition of nitrogen in magnesium thiocyanate. Now, you will notice for this, you didn't get the formula, so you're going to have to come up with that on your own. So we'll briefly go over how you're going to take care of that. Magnesium is a metal, thiocyanate is a polyatomic ion. That makes this an ionic compound. Because it's ionic, you will write the ions. Magnesium is a +2, thiocyanate is SCN -1. You will crisscross. I knew to do that again because it's ionic. So the compound is Mg parentheses SCN2. Very important I write that correctly because if I don't, my masses are going to be all over the place. So now we're ready to find the molar mass. So we have magnesium and sulfur and carbon and nitrogen. There's 1 magnesium, and then this 2 on the outside of the parentheses, you're going to multiply it by each subscript inside, so you're going to have 2 sulfurs, 2 carbons, and 2 nitrogens. Just a good little review for you right there. And now we're going to look up the molar masses on the periodic table. So the molar mass of magnesium is 24.31 grams per mole. The molar mass of sulfur is 32.07. The molar mass of carbon is 12.01. A lot of these you probably know and don't even have to look up at this point. And the molar mass of nitrogen is 14.01. So let's multiply everything out so we can get our total mass of each individual atom represented. So we're going to have 24.31 grams per mole for magnesium, 64.14 grams per mole for sulfur, 24.02 grams per mole of carbon, and 28.02 grams per mole for nitrogen. Add them up to get the total mass of that molecule, and you're going to get about 140.49 grams per mole. Now we're ready to solve for the percent nitrogen. Sometimes once you've done all that work, you actually have to look back up here and say, I've already forgotten what they were looking for. So to find the percent nitrogen, we are going to be dividing the total nitrogen, which is 28.02, by the total of the whole thing, which is 140.49. So percent nitrogen equals 28.02 grams per mole divided by the total, which is 140.49 grams per mole, times 100. When we punch that in, you should be getting about 20% nitrogen. So that was a good little review as well on how to handle parentheses when you're finding molar mass. So we have one more that we're going to do together, and then I'm going to give you a few to try on your own. So number 4 says, what is the percent oxygen in aluminum sulfate? And you'll notice that's worded a little bit differently than number 3. I did that on purpose. I just want you to see it's the same thing. So I didn't put composition in there, but you just kind of know that at this point. So aluminum sulfate is an ionic compound, and I know that aluminum has a +3. Sulfate is SO4 -2, and when you crisscross, I know to do that because it's ionic, you're going to get Al2, SO4, 3. So I'm going to use that now, and I am going to find the molar mass of aluminum sulfate. So let's take an atom inventory. We have aluminum, sulfur, and oxygen. We have 2 aluminums. We have 3 times an understood 1, 3 sulfurs, and then 3 times 4, 12 oxygens. So we're going to multiply these out. Aluminum has a mass of 26.98. Sulfur has a mass of 32.07. And oxygen has a mass of 16.0. Let's multiply it out. 2 times 26.98 is 53.96 grams per mole. 3 times 32.07 is going to be 96.21 grams per mole. And 12 times 16 is 192.0 grams per mole. And again, you know, technically I really should be writing gram per mole here, but this is still kind of in the scratch work phase. Add them together and you get 342.17 gram per mole. So we look back up at the problem to say, okay, what were they even asking me for? They wanted the percent oxygen. That means I'm going to divide the total oxygen by the total mass of the molecule. So percent oxygen equals 192.0 grams per mole divided by 342.17 grams per mole times 100. And that gives us about 56% oxygen. Now, something I want to point out real quickly is if you've already watched the hydrate video, the math is really similar. In the hydrate video, we were solving 4% water. So we divided the total water by the total of the whole thing. The only difference here is these aren't hydrates and we're solving just for maybe one specific element. Per the molecule, there's just not water involved here, but the math is still the same. It's the total of what you want, what you're looking for specifically, over the total of the whole thing. So now I've got 2 for you to try, and once you know how to do these, then you can officially say you have graduated from calculating percent composition. So what I want you to do is take a second and copy these 2 down. You notice these are written just a hair differently. Calculate the percent phosphorus in pentaphosphorus decoxide. Calculate the percent carbon in calcium hydrogen carbonate. Same type of question. So if you'll pause the video here and write these down, we're going to come back and I'm going to give you all the answers so you can see how you did. So here are the answers for those 2 questions. We'll look at number 1 first. So calculating the percent phosphorus in pentaphosphorus decoxide, you can see we found the molar mass and we divided the total mass of phosphorus by the total of the whole thing. So you should have gotten about 49%. Hopefully everybody was really close to that. So if you made a mistake on it, this is a great time to check, see if you can locate maybe what you did wrong. Typically it's something simple like maybe looking up the wrong mass on the periodic table, maybe just putting something in the calculator incorrectly. Happens to me all the time, so it's just an easy mistake to make. And now let's look at the next one, the percent carbon in calcium hydrogen carbonate. Again, we tallied up that total mass, which was 162.12. We put the total mass of carbon, which in this case was 24.02, over the total mass of the whole thing. giving us about 15% carbon. So that is the end of the percent composition by mass lesson. Again, it is very similar to the lesson on hydrates. If you had any trouble on calculating molar mass, make sure you go back and check out my YouTube video on molar mass, and that should fix you right up and you'll be able to move on.